My name is Pratham Aloya. My student roll number is 2510994816. In this video, I'll be explaining my code of the task 5.1P. The program I created in this is called Zoopark, and it demonstrates my understanding of OOPS concepts in C Sharp, including classes, inheritance, method, overriding, and multi-level inheritance. I'll walk through each question one by one. In question 1, I created a base animal class without any inheritance. It has 6 private fields: name, diet, location, weight, age, and color. These are private because we don't want them accessed directly from outside the class. The constructor takes all 6 values and assigns them. I then defined 3 virtual methods: eat, sleep, make noise, uh, which just print generic animal behavior. I made them virtual so that subclasses can override them later. In the main method, I created 3 animal objects: a wolf, a tiger, and an eagle, and call their methods, which all print the generic animal responses. Question 2. I created subclasses that inherit from animals like tiger, wolf, eagle. Each extend animal and have their own constructor that call the base constructor using the base keyword to pass the common fields. Eagle has an eagle 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 has an additional method called lay eggs and also called fly, which are specific to eagle only. uh, this way I can by adding this extra method, I demonstrated that subclasses can also have their own unique methods on top of what they inherit. Question 3, method overriding. I overrode the virtual methods from animal in each subclass. For example, tiger overeats eat. To print, it can eat 20 lbs of meats. To make noise, uh, tiger class. Right. Yes. So I also wolf overrides eat and make noise with its own behavior. Eagle overrides eat and make noise too. I also added a creative fourth virtual method called move in the animal class and overrode it in every subclass. Tiger prowls, wolf runs in a pack, eagle soars. This shows polymorphism. The same method name produces different behavior depending on which object calls it. In question 4, I introduce mid-level classes feline and bird. To create a multi-level inheritance chain. Instead of tiger inheriting directly from animal, tiger now inherits from feline, which uh, ti- tiger this. Similarly, eagle and penguin both inherit from bird, which inherits from animals. Feline overrides sleep so that both tiger and lion inherit that sleeping behavior from feline rather than animal. Bird adds a virtual fly method so eagle and penguin can override it differently. Eagle soars, but penguin prints that it cannot fly. I also added lion and penguin as new animals. This demonstrates how multi-level inheritance allowed shared behavior to be defined at the right level of the chain. In question 5, output prediction. I created 3 simple classes A, B, and C. Here they are. To demonstrate the difference between override and new keywords, class A has M1 as virtual and M2 as a regular method. Class B overrides M1 using override and hides M2 using the new keyword. Class C inherits from B and overrides M1 again when we call a.m1 we get A's M1. When we call B dot M1, we get B's M1. Because B overrides it, when we call A dot M2 and B dot M2, both prints their own version because M2 uses new, which hides rather than overrides. When we call C dot M1, we get C's M1 because C overrides it. When we call C M2, we get B's M2 because C never overrides M2, so it inherits from B. Overall, this program covers the core pillars of object-oriented programming: encapsulation through private fields, inheritance through animal hierarchy, polymorphism through method overwriting, and abstraction through base animal class defining common behavior.